Good day, guys. So we are here once again, and in our last video, I told you guys how to install the Kicad software and how to put it on your system. And now we'll be looking at how to actually use the software. So once you have installed the software, just open it, and this will be the first window on your screen. This will be the first window on your screen. So don't mind this here. This is just a project I'm working on. So this part, this widget is just telling us the various stuffs that are here. So we have here the schematic editor. With this, if we click on this, we'll open the schematic editor where we can draw our circuits and add our circuit symbols and others. Then we'll have the symbol editor also, which is for symbol creation. Then we'll also have the PCB editor. This where we'll do our actual PCB layout. We are going to see all this as we proceed further in the class. This shall do our actual PCB layout, where you draw your traces, you draw your routes, and you design your PCB and place your component as intended based on your specific application. Then we'll also have the footprint editor. We'll have the GABA view. We'll talk about GABA view during the end of the classes. Then and every other stuff. Also have the PCB calculator here and every other stuff. But once you're on this widget, first thing to do, you need to learn how to start a project using the Kicad software. So first, you come to files, you click on files, you click on new project. So you click on new project, then you go to a directory on your system, or you can create any directory at all where you save your projects on. So let me just do a new folder here and name it um let me name it test. Let me just name it test. Yeah. So I come to test. So on this one, we need to give the project, the Kicad project file a name. I need to give the Kicad project file a name. So let me name it IoT node. So this is just a generic name, IoT node. Then I save. So once I saved, you have seen this here. This is the schematic file, and this is the PCB file. So we'll be going first into the schematic file, and we'll be looking at what are the stuff that are there and how we can navigate and actually create a simple design on the schematic. So you click on it, and yeah, it opens up this widget. Remember, we're using Kicad 9. It opens up these windows. So on this windows, we are seeing so many stuff here, and there are so many things here that we can look out for and we can actually use. And everything you're seeing here, every window, every icon, they are very important on your design phase. So first thing I will do, here is your sheet. So here is your sheet. You can zoom in and zoom out. So I'll also show you guys how to use shortcuts. So for zooming in, I normally use F1. F1 is to zoom in and F2 is to zoom out. So the shortcuts I'll be using, I'll also be telling you guys. So if you come here, this is the sheet. If you come here, you can see the file name IoT node dot Kicad SCH, which is schematic. IoT node and Kicad schematic file. That's what it means. And this page is actually, the size of this page is actually an A4 size. You get, it's actually an A4 size. You can actually increase the size of the sheet. You can increase the size of the sheet if you're designing a more complex board that it can't contain on an A4 sheet. You can increase the size. So let's do the page setup first. So to set up the page, what you need to do, you click on files, then you come to okay guys, just hold on, let me check something. Okay, yeah. So you click on files, then you come to page settings. So you click on page settings, then you've seen the size here. This is A4. So you can increase the size as you want. We have A5, we have A3, we have A2, we have A1. But I normally use A4 for smaller projects. I use A3 for larger projects. And if the project is very large, then I go to hierarchy sheet which I'll show you guys later. So let me just put A3. Yeah. So again, the date. So today's date is 14th January. You can put your custom date here, or you can just put any date you want. If you just want it to reflect, you just click on this. So it will just reflect. Then revision. So this is, let me say this is version 1. Version 1. Then the title of the project. Okay, we can name it IoT node schematic or IoT node design. Anyone, you can just give it any name. Then the company, you can put all this. It's not really necessary, but you can also put it just for reference. So the company, PCB mentor, and comment. You can put any comment you want. So yeah, this is just the basic stuff I can do here. And you can also make this sheet exportable, you get. So in case you have about, let's say in case you want to use this particular sheet on another design, you can actually make it exportable. You can use this. So I just click on OK. So let's go. So you've seen it, the size of this have increased. So at this point, PCB mentor, this is the file name, IoT node. This is the title, IoT node design, and the size is A3, and this is the date. So that is for the page setup. You can set the page as you want to do. So what I can come here now, and yeah. So let's talk about the icons and every other stuff that is here that will be useful to us in our design. Okay, so at this point, this can come out like this, or you might not even see this. So it might be like this when you open up your own file. So for this point, this is the hierarchy navigator. Yes. In case you're using a hierarchy sheet, yes. This is the hierarchy navigator. I'll talk about this later on. But let's start with these icons on this place. Okay, so here is your normal cursor. Now I'll talk about majorly on the main ones that we'll need. So the ones that I want to talk about maybe during the design, I might use them and you might see how they are being used on design and development. So on this point, we have our place symbol. So this is the place symbol icon. So on this point is where all your schematic symbol, all your component symbol are. You get either your microcontrollers, either your IC regulators, either your sensors, your component symbol. That's where they are. You get. And what are component symbols? Component symbols are just a they're just what is being used to identify a particular component during schematic design or in a schematic design or your circuit design. Yes, they are components, they act as components identification format. Okay, so first of all, we'll click on this. So to open it, you just click on it. So once you click on it, it will be loading. Then yeah, we have gotten our windows. So what you need to do again is depending on the component you want to use on your design. So let's say, for example, I want to use a resistor. I can search here on the filter bar, or I can just come to this part and look for where resistor is. I can come to this part, look for where resistor is, and I should find, yes, I should find a resistor, arrow reference, resistor. So in case you're finding it difficult to get it, you can just search for resistor here on this resistor. And now you can see this actual symbol of a resistor. So once you've gotten it like this, you just click on it. You click, then you zoom in. You're saying this is your resistor, and your resistor is being placed on your schematic sheet. So this is the reference. This is the reference number you get of the resistor R1. Remember, the resistor, their annotation is actually R. Capacitors is C. ICs might be U. depending, you get. Then at this point here, you can put the value of the resistor. I'll talk about this later. Then let me see if I can take any other component. Let me search for capacitor. Capacitor. Okay, this is a capacitor also. I can click on this and yeah. So these have to select symbols. These have to select symbols on the Kicad software. You just go to the symbol, the place symbol icon, then you click on it, then you search for the symbol you want. I can also search for microcontrollers. Let's say I don't know if you guys know the STM32 or the ESP32 microcontrollers. So let me say I need an STM32 microcontroller on my design. I can come here and search for it because the library. KiCad has lots of component library. Yeah, they have lots of component library. But in case the component you need to use, the exact component you need to use is not on the KiCad library, we can do either one or two things. We can either import the library online, the symbol library online, which I'll show you guys how to do it, or we create our own custom library using the symbol editor. I'll show you guys how to do the two ways. Okay, I want to use an STM32 chip. So let me just go with this. I guess so. We don't really have any one in mind. So I just went with this. So you have seen it. This is how we bring components to our schematic sheet. So the next icon here is place power symbol. So this is majorly for power symbol like the ground connection. If your system is operating with 12-volt power rails, 5-volt power rails, 3.3-volt power rails, you can actually get all that. And on this point, you get these are the power symbols. So let's say for ground, it's majorly symbolized with GND. Yeah, so we are seeing it ground. We have ground one, we have ground two. So all these ground one, ground two, is just if your application or your design has various ground levels, you can actually use the different ground symbol to separate them, okay, or to identify them. We also have Earth here. But just for the purpose of this, we'll be using the normal ground. So this is normal ground symbol, and yeah, we'll put it at this point. So we can also, so what I did, if you check now, my cursor still has the place ground symbol on it. So I can just click on the sheet and it will just open automatically. So let's say I need about 12 volts power. So I can click on 12 volts and plus 12 volts. You know, we have the negative polarization and we'll have the positive polarization based on your system power requirement. But majorly, we do use the positive polarization except you're designing, let's say, either an up arm or something else. Okay, so I go with this 12 volts, blah, and yeah, I have my symbol. So I have my power line and I also have my ground connection. And I have my resistor, I have my capacitor, I have my microcontroller. Yeah. So I'm just doing an overview, guys, on how to use the Kicad software. We'll go into our main design later on, where I'll show you guys how to select components, how to place this, and how to do that. So the next stuff is okay. Let's just do like a practice, just like a run through. So this is a resistor. Let's say this resistor will be connected at this point. Okay, yeah. So to rotate, you can rotate in either way. You can come to the click on the component, then right click on your mouse. Then at this point, you can search for uh, rotate. Okay, move, drag. You can search, I guess rotate should be here. Um, so what I normally do to rotate, once I'm on the component, I press arrow, just arrow, it rotates. Yes. If you just press arrow on any component you are, it will just rotate. Just arrow, it will rotate. So that's what I normally do to rotate my symbol, both on this schematic sheet and on the PCB layout, which I'll show you guys as we proceed. So yeah, this is it. So let's say we'll keep it at this point. Then Let's say we'll keep this capacitor at this point. Okay, so the next symbol, the next icon is the draw wire. This draw wire is where you need to connect the components together. You guys, you want to connect the pin of the component, either the microcontroller and the capacitor or the resistor and any component where you establish your connection. It's just like normal wire. When you're doing a breadboard design, the normal wire connection, this is what it is on the software. So draw wire. So I can click on it. Once I'm on it, you've seen it. So what I can do is I come to this point where the pin is. I come to this point there. I just click once, then it's the connection has been established. Then let me say I want to put it at this point. Once it's at this point, I just click once also, and I've established my connection. So let's say I need to put my ground this thing here. Yeah, and to grab a component, yes, I click on a component, or to move a component, I click on a component, then I press the letter M. M. So M is to move. Once I click on M, then I can now start moving it with my cursor, I guess, or your mouse. I can start moving to my mouse. Then I click on this. Then I can come to this point, draw wire. But even though you don't come to draw wire, Kicad have already made it easy for us. Once you come near the pin, the draw wire symbol will just come immediately. Then you can just click on it once. Then bam, you have established connection within these 2 points. So same thing here. So okay, let me say for this point, I need this resist. So again, press M, then move. Yeah. So here, click on this, press M, then move. Here, to zoom in, F1, then click here. Then to copy, you can still go to this point and take the ground symbol, but you can just copy it. You can copy it by click on this stuff, then right click. You should see there should be a place to copy. You're seeing copy. You can copy and all that, but normally I'll just click on it, then press Ctrl D. It will duplicate. It will duplicate. Then come here. Then just establish my connection. Bam. And these guys. You get, so I've gotten this point. Then another one I will tell you guys. I want to tell you guys this too for now. Another one I'll tell you guys is place no connection flag. So this no connection flag is important. Let's say we are done with our design and we still have other pins that are not connected. Most times when we are done with our design, we have pins that are not connected. If we want to move into the next stage, the Kicad software can generate an error that a pin or certain pins are not connected. So to remove that error, what you need to do is to take this place no connection flag. You take it, once you click on it, this how it is, then you can just start putting it here. So you just come to this place, then click it to enter, click it to enter, click it to enter. So that is for that. Then what again, I don't want to explain so much. So okay, let me explain this. So place net label. I'll explain this, then I'll move to the next stuff. Place net labels. So what are net labels? Net labels, they are connections, but they are connections in form of write-ups. You get. So let's say you're designing a very complex board, and let me take another symbol. Let me take something like a sensor. Which sensor? Okay, we have pressure sensor. Yeah, let me take something like a sensor. Okay, this is a sensor. This is a sensor. So I just click on this. I'm just choosing a random sensor from this. I just click on this, and let's say this sensor is at this point of the design. Yes, and I'll need to establish connection within from pin PB9 to pin 5 of this sensor. I'll need to establish connection, and I don't want to start making this diagram like this, drawing it to come to this point. It might just make my schematic messy. You get. So to avoid this messy stuff, Ctrl Z to remove. To avoid this messy stuff, we can use what we call the net labels. So I come here. Once I click on net labels, so it will tell you to put the name of the net label you want. So you can just put the name you want to put here that will identify that particular connection. So let's see, let me check the component. Hold on first. So the component name is BMP280. Okay, let me just use this name, BMP280 MCU. I'm just using this since it's connected to the MC. They're connected to the MCU. So just for example, you can put any name, but make sure that the name you put is relatable and can be understood. Okay, I click on this. So what you can do once you click on OK to come like this. So again, you can rotate with arrow. Then come here, put it here. Then you can either decide to write the same name or you can just duplicate it by pressing Ctrl D to duplicate. Then I come to this point. Sorry. So arrow is to rotate. I come to this point and I place it. So the connection has been established. Yeah. So what this means is that this pin here, pin 62 here, and this other pin here, they have been connected. They are connected together. You get? They're actually connected together. That's what this means. Get it, guys? Yeah. So that is for the net name. So what again? Just looking for the ones that will be relevant for us. Okay. Okay, let me just talk about hierarchy sheet. So if you want to create a hierarchy sheet, let's say you have a complex design and so many things on the design. I want to create a hierarchy sheet. So as I'm talking about the hierarchy sheet now, I'll also talk about this widget that's here. So you have a complex design, so many components, you have thousands of components on your design, and you need to structure your design in a way that can be understandable and relatable and also readable to external individuals and also clear on your eyes also. So what you can do is you come to hierarchy sheet, uh, click on hierarchy sheet, then this will come out, then you can click on this thing. So you can just make it how you want, like the size you want. Then you can name the sheet. So let's name it power. Let's name it power node. Yeah, then the sheet file name. So you can name it IoT node power PWR. Yes, then okay. So once you press OK, you've created another sheet. So what you can do, if you check at this point now, we have our root sheet and we have another sub sheet. So these are the hierarchy sheets on the root sheet. We have another sub sheet on this point. So if I click on this stuff here, if I double click on it, it will take me into the next sheet, which is the power node sheet. So I just double click. Now I'm in the next sheet. So I can check here also. So this sheet now is A4. I can decide to I can decide to do another sheet setup, making this, putting titles and all that here. So you can also navigate various sheets with this point. And you can come to the root sheet via here, you can come to this point, or you can just click on this and you enter the sheet. And the same thing, so once you're on this sheet, you can also start doing other design, bringing your components and every other stuff. Yeah, so that's how the hierarchy sheet works. Yeah. Then I'll tell you guys also about the something that's important for the hierarchy sheet, which is the place global label. So place global label is important. So to establish connection within an uh, a hierarchy sheet and other hierarchy sheets or different sheets on the design. We have different methods that we can use, but I'll just show you guys this on about the place global label. So let me get a component. So let me see, let me get this component. I'm just doing random stuff here. So get this component, I place here, and let's say I want to establish connection within this CS and this pin 30. So if I want to do that, if I use the net label, if I use the normal net label, so let me say LPS22, so for MCU. Okay, if I use this normal label and I still take this, copy this, and put on the root sheet. Sorry, this, let me just copy the text. Copy the text and put on the root sheet. Let me see, copy this there. Okay, this is the text. Yeah. So I'm put on the root sheet. Here, connection is not established within this sheet and the other sheet. Why? This net label is just for same sheet. It just establishes connection within its main sheet. It is a established connection within this sheet that it is. So if you're moving into another sheet, a connection is not being established. So to establish a connection, you need to use what we call the global label, not the net label. So the global label, name it LP MCU. So this is the global label. So with this global label, you can establish connection within various sheets in your design. We'll also have other ways to do that, but yeah, this is just the way I'm showing you guys. So I can establish connection in this point, and I can copy this and establish connection also in this point because they are in two different sheets. Okay, so that's how to do that, guys. Okay, I come back to this point. Then this is just text. In case you want to put text on your design, let's say you want to label a section of your design, MCU. You can also increase the height and let me make this 100. So you're seeing it and just put it here. These are text that you can put. Yeah. So this for this today, guys. So I'll continue next time with you guys. So subscribe, share, like, and also tell our people around about this course. It is a wonderful course, guys. So yeah. Also comment